There's a lot of technical talk out there about autophagy and the way people present it, and I can't avoid being super technical, so I'm going to go into some very technical things here. So please stay with me. Don't go get coffee. Don't go to the bathroom. You need to focus here. This is complicated. Here we go. What is autophagy? What is the process like? Here's the analogy I came up with. It's Pac-Man. It's just like Pac-Man. Pac-Man goes around, eats up all the clutter out of the street. Let's go a little bit further. Where does it happen? It happens in the cell. Autophagy, we talk about the system-wide effect, but it's happening in each cell. Those are proteins. See that protein? That's what Pac-Man's eating up. Proteins, proteins, proteins. Pac-Man is a protein, but he's eating protein. Okay, little proteins, bigger proteins, complicated proteins, all different kinds, especially when they're ill, when we're in the repair state with a lot of autophagy, and that's where it happens right there. That blue wavy stuff around that nucleus, that's the smooth endoplasmic reticulum. That is the sustainability element of our cell. 50% of our cell mass is smooth endoplasmic reticulum for recycling and sustainability. That's where it happens. Pac-Man eats it up, brings it in there, and that's where the recycling process happens right there. All right, very important. The other side of that equation, you see it, there's the recycling, is energy production. That's a mitochondria. Those are little non-human centric cells that live with us and produce packages of energy. They do not produce energy. They repackage energy that we can use in other places called ATP. We can talk about that in another video. So they are called the powerhouses of the cell, and they make little energy packages. Energy package, energy package, energy package. They make a lot. Without them, we'd be in trouble. Okay, big time. And Pac-Man loves energy. We know when he gets a power up, gets one of those big dots in the corner, then even his enemies become food, right? But when he gets old, he gets worn down, he's not working so well. Guess what happens? Those ghosts, those enemies, they catch up to him and they get him. And he will get recycled too. That's okay. That's the life of the mitochondria, and that's part of Pac-Man's job. That's part of our recycling process. Up there, we see that we have a protein that's not doing well. It's not folding well. It's causing a problem. Maybe it's an advanced glycation end product, which is a aging product within us. AGES is the acronym, ironically enough, and so forth. And when that gets identified, guess what? Pac-Man's on his way, and that becomes an enemy. That becomes a ghost. So Pac-Man's in there looking for debris, looking for things it needs to neutralize. It could be a virus, could be a bacteria, it could be debris, it could be the biomass that we talked about earlier, but that's what's going on. So what ends up happening? More recycling as this gets more and more efficient. More recycling, becoming more efficient. That's what happens in autophagy. The stronger, more efficient that state, the more of this that goes on. That's the battle and the balance between recycling and energy production. Right there, the two most fundamental mechanisms, metabolic processes in our body that keep us and every cell within us alive. When they're out of balance, my friends, game over. You've seen it. Now, if you don't know who Pac-Man is, I don't want to hear it. Okay, those of you do, I think you get it. I hope you liked it.